This is the fourth in the Which Test series of videos. These videos will help you decide which specific hypothesis test to use when faced with a free response type question that needs a hypothesis test. In this video, I discuss in more detail when to use the three different chi-square tests. These three M&M examples illustrate the differences between the three chi-square tests. First, in a random sample of 100 plain M&Ms, there were 23 brown, 18 yellow, 15 red, 15 orange, 5 green, and 24 blue candies. Does this match the color distribution reported on the Mars website? First, let's look at the variables. I have only one variable, color. It's clearly categorical with 6 different categories. So the 6 categories means I'm in chi-square. I have one sample, a random sample of 100 M&Ms. So I have one variable, more than 2 categories, one sample. This is chi-square goodness of fit. In goodness of fit, we're always interested in whether or not the distribution of our single variable for our single sample matches some given distribution or some assumed distribution. Number 2, in random samples of 100 plain, 100 peanut, and 100 pretzel M&Ms, the color of each M&M was noted and the data are presented in the following table. Is the distribution of colors of M&Ms the same for all 3 types? Again, I have just one variable, color, but now I have 3 samples. We had random samples of plain, peanut, and pretzel M&Ms. The one variable has 6 categories, but since I have 3 samples, it doesn't really matter how many categories it has. This must be the chi-square test of homogeneity. In the chi-square test of homogeneity, we're always interested in whether or not the distribution of our single variable is the same in all of the samples. Last one. In a random sample of a mixture of plain peanut and pretzel M&Ms, the following distributions of colors were found. Are type and color of M&Ms associated? We're back now to just one sample. Now, for each M&M in the sample, we note the type of M&M and the color of M&M. So I have 2 variables, type and color. They're categorical variables. Anytime I have 2 categorical variables, it must be association. In this case, type has 3 categories, color has 6, but it really doesn't matter the number of categories. If I have 2 variables, it must be the chi-square test of association. Notice that the two-way tables in examples 2 and 3 are exactly the same. To tell the difference between homogeneity and association, we look at the number of samples. If we have more than one sample, it's going to be homogeneity. If we have only one sample and 2 variables, it will be association. These 2 hypothesis tests are very, very similar. The mechanics of both of them are exactly the same. The only differences will be in the wording of the hypotheses and the wording of the conclusions. Again, in homogeneity, we're interested in whether the distribution of our single variable is the same for all of our samples. In association, we're interested in whether or not the 2 variables are associated or independent. The keys are the number of variables, 1 or 2, and the number of samples, 1 or more than 1. I'm going to go through a couple of examples from old AP exams to illustrate a little more how to decide which test to use. This first example is from the 2013 AP exam. The Behavioral Risk Factor Surveillance System is an ongoing health survey system, blah, blah, blah. In one of their studies, a random sample of 8,866 adults answered the question, do you consume 5 or more servings of fruits and vegetables per day? The data are summarized by response and age group in the frequency table below. So we have one sample. Each person in the sample was asked their age and whether or not they eat fruits and vegetables every day. So I have two variables, age and whether or not they eat fruits and vegetables per day. These are both categorical variables. Two categorical variables means chi-square test of association. If, instead of one sample, the researchers had taken a sample of adults 18 to 34, a separate sample ages 35 to 54, and a third sample ages 55 and older, we would have had 3 independent samples, and that would have been a test of homogeneity. They might have asked the question in exactly the same way to see if there's an association between age group and whether or not a person consumes 5 or more servings of fruits and vegetables. But if I had had 3 independent samples, it would have been homogeneity instead of association. This is from the 2008 AP exam. A study was conducted to determine where moose are found in a region containing a large burned area. A map of the study area was partitioned into the following 4 habitat types, 1, 2, 3, and 4. And the type, they're shown in this figure below. The proportion of total acreage in each of the habitat types was determined for the study area. Using an aerial survey, moose locations were observed and classified into one of the 4 habitat types. The results are given in the table below. The researchers who are conducting the study expect the number of moose observed in a habitat type to be proportional to the amount of acreage of that type of habitat. Are the data consistent with this expectation? Conduct an appropriate statistical test. That's our key. That's telling us that we're going to do a hypothesis test. This seems like a very complicated problem, but as soon as we determine specifically which hypothesis test to use, it becomes easy. We simply do our test to answer the question. So let's look at our variable. We have only one variable, moose locations. That's the only thing they determined. It's clearly categorical with 4 categories. We look to see how many moose were in each habitat type. So I have one categorical variable with 4 categories. So this is clearly a chi-square test. I have only one sample. They used one aerial survey. So I have one categorical variable, 4 categories, one sample. This must be chi-square goodness of fit. And as soon as I know it's a goodness of fit test, I will perform the test, and then I'll be able to answer the questions. To summarize, if you have one sample, one categorical variable, more than 2 categories, it's chi-square goodness of fit. If you have one sample with 2 categorical variables, it's the chi-square test of association regardless of the number of categories. If I have 2 or more independent samples, one categorical variable, two or more categories, it's the chi-square test of homogeneity. If I only had two independent samples, one variable with only two categories, that would be the two-sample z-test for difference of proportions. But if I have more than two samples or more than two categories, then we have to use chi-square test of homogeneity. In the special case where I have three or more independent samples with only one categorical variable, it's always going to be chi-square test of homogeneity regardless of the number of categories. If you have any questions and would like a fast response, email me at apstatstutor25@gmail.com, or if you prefer, post your question in the comment box below. If you're interested in tutoring, I offer one-on-one tutoring, either in person or online. Contact me again, apstatstutor25@gmail.com for details. If you found this video to be helpful, please like the video and tell all your friends about me. Thanks for watching.